Hello everyone. Today we are going to discuss Kubernetes deployment. What deployment object is, why is it needed, what problem it solves. So let's say you have a sample service which has 3 replicas managed by a replica set. And the flow is that you have 3 pods managed by this replica set and a service object. The client talks to service object and service points delegates the call to one of these 3 pods. Now, deployment is needed when you want to upgrade your application to a newer version and you want to deploy that version in the production. Now, how do you deploy so it provides deployment strategies for the new version of your application. So there are 2 ways in general, how can you upgrade your application to production? There are 2 ways at a high level. One way is you delete everything, delete the earlier version of your application, and then come up with a new version, which means that your service will be unavailable for certain time. Because once you delete older version of application and come up with new, there'll be some gap, a second or few seconds or a minute or something. The other strategy, start new pods or new versions and delete the old ones. Now, even within that, there are 2 ways to handle this. One is called blue-green deployment, and second is called a rolling update. And we'll see diagram of these 2 also in the coming slides. So in blue-green deployment, you spin up all new pods or all new versions and then delete the old ones. In the rolling update, you do it one by one. So spin up a new version and delete the old one by one. Right? Spin up another new one. Sorry, it should be new one and then delete the other old. So you can use rolling update when your newer version and the older version can coexist. Basically, your newer version is backward compatible. For the blue-green deployment, you can go and look into this link. What it has been explained in detail here. So basically, there are 2 parallel deployments. The old version is running on service A. For example, when you say old version, I mean the old pods are running under service A, and the new pods are deployed on service B. Once all ports in service B are up, then service starts pointing to B, and the ports in A can be shut down. The A is managed by version 1 of the replica set, which deals with earlier pod. B is managed by version 2 of replica set, which deals with new pod. And the replica sets are created automatically. So we'll see how this whole flow is automated using deployment. So blue-green deployment, the way it works is you see blue and then you see green here. So you have one replica set version 1 managing this port, services pointing to this. You come up with the new version, a new replica set with the new versions of your pod, and then service starts pointing to that. And you can delete these pods. You don't delete the replica set, and we'll see why. The rolling update is one by one. So you have 3 pods managed by replica set version 1. Now you come up with replica set version 2. So let's talk about replica set version 2. What does it contain? So replica set, as mentioned, is managing the pod, and there's a pod template. The pod definition points to the image and the version, the Docker image in our example, and the version of that image. And that image is of your application. So when you add new features to your application, and then you create a new image of your application with a newer version, and you want that image to be to be used in the pods using replica sets. So this replica set version 2 has the newer version of your image. So what the older version of your the pod C is managed by replica set v1, which has the older version of your code of your application. So in first step, this pod C goes down, and the new pod C will be managed by the replica set version 2. Then pod P will go down, and in place of that new pod P will come up, which will be managed by version 2 of your replica set. And eventually all pods will be managed by the newer version of the replica set. and the replica set version 1 we will remain, and we'll see the reason later. So deployment is essentially a resource for deploying application and updating them declaratively. So when you create a deployment, it creates a replica set underneath, and that replica set creates the number of pods underneath. Now, why an extra deployment resource is needed by Kubernetes? See, if you do all of this, deployment, the version upgrade of your application in production yourself, it's quite complex process, and there's a chance of you making mistakes as well. So deployment resource from Kubernetes makes all this process easier for you, and we'll see demo of that. So it's helpful, for example, when we have two versions of the app running during app update. These two versions will be controlled by two different replica sets. Removing early version pod and adding new version pod will cause a lot of complexities if you do it yourself without using the deployment object. So deployment makes it easier. So we'll see the deployment file. So let's go through this. In this deployment file, you have in this YAML file, you have this kind defined as deployment. And then you have this spec, and then this is the name of your deployment. And you have the spec, and you are using 3 replicas. So this is a replica set sort of template. And this is the label you are giving, a tips app. And this is the pod template. This pod template will have the metadata, and this is the name of the pod template also. Apparently, I have given the same name to the pod as well. And this is the label of your pod. This label should match this label. This is a deployment label, and this is your pod label. And this is the pod definition. We call this thing as pod temp. This containers image. And if you see, this is the version of the image. So this is part of the pod template. So now what we'll do is we'll create this deployment. And what are we expecting once we create this deployment? We'll see at very high level, a deployment object getting created. That deployment object will create a replica set. That replica set will create a pod with 3 replicas. And we'll see how this works. I had already created that, so let me delete that first. Come here, cube ctl get deployments. So I was playing around with that, so let me delete this. Cube ctl delete delete deployment. So it got deleted. Now there's no deployment. So let's see the deployment YAML. There's the same thing which I showed you. So this is a replica set. So this is a deployment with tips app. There's a replica set which has this label, and then it has the port definition, which is using this image and this version of the image, right? Latest version of the image. So let's create it. Cube ctl create and deployments. So this deployment got created, and if you see the deployment, you will see deployment with this name got created. Now, if you see the pods, you will see the pods also got created. Now, these pods have this, some characters here. What these characters are, we'll discuss that. Now you can check the status of your deployment using this rollout status command also. So let's see this cube ctl rollout status deployment command. So it says the deployment tips app successfully rolled out, correct? So deployment creates a deployment object. Then it creates a replica set. Replica set creates pods and manage those pods. And we have seen the pods already getting created. Now what we are going to see is we're going to see the replica set. So kubectl get replica set. Now if you see one thing, this is the name of the replica set. This name has this hash. And this hash is same as the name of this characters appearing after in the pods when we say get pods. Now what this hash is the hash of the pod template here. So we have defined the pod template here, right? So this is the hash. Now what does this mean? The the name of the image and the version of the image is part of the hash. So if we change the version of the image, then a new hash will be created. It won't be the same hash. Now, why I'm saying that, you will come to know when we upgrade the application with the newer version. So this is just I explained. So number in the name indicates a hash of the port template. So in the replica set and the ports, it's same. So when we upgrade using rolling update, you will see ports with 2 hash numbers. Now what we are going to do is, so this we have tested. When we upgrade it, I will show you how to upgrade, and you will see the 2 hashes appearing in the, there'll be 2 replica set, each one is its own hash, and there'll be ports. As and when the ports are moving from older version to new versions, you will see the hashes also getting changed for the ports. So deployment strategies, we have seen that. So for update, we have gone through that earlier. Just refreshing those. For updating the app, below deployment strategies are available: recreate and rolling update. So what does recreate do? Recreate first delete all ports, then create new ports with new version. Only one version, either old or new, exists at the same time. In this case, app will be unavailable for short period of time. The other deployment strategy is rolling update, and we have seen example in the diagram of that already. It deletes all ports one by one while adding new at the same time. So apps are always available. It's a default strategy in the deployment, and we should use that as much as we can. And specifically, when and in one requirement for this is the 2 versions, the older version, the newer version, which we are trying to update to, should coexist at the same time. Now what we want to do is, we want to see when we do the rolling update, we want to see the ports getting changed one by one. To simulate that, we can see the old version port and the new version port. We're going to set some min ready seconds configuration in the deployment. Now, what this min ready? So here the reason we want to set this up is will be arbitrarily slowing down the updates so that you can see the ports with older version and new version. If you don't do it, that the Kubernetes will immediately change the ports to the newer version, and you'll immediately start seeing the newer version. So here I want to see one by one port getting upgraded to the newer version. Now what this min ready seconds is exactly. So this seconds is an optional field which specifies the minimum number of seconds for which a newly created port should be ready without any of its container crashing for it to be considered available. So basically what it is saying is, this I copied from the definition of the min ready seconds. What it is saying, and you can see that using explain command. So you can say deployment spec min ready second. So so when port gets upgraded, when you upgrade the port will be there, but it will not be available for 10 seconds, because you have set this min ready seconds value to 10 seconds. Pod has started, but it's not available for 10 seconds. It will wait for 10 seconds if the container is not crashing. But if pod is up and before 10-second container crash, then of course it won't be available. So container should be up and code should be up, the pod should be up. So for 10 seconds, it's not available yet. After 10 seconds, it will become available. So that's what min ready seconds is. So I will set this settings. So let's see. kubectl patch. So this is the setting. So it got set. Now if you see kubectl get ports now, and you get the replica set also. Oh, sorry, we have changed only the, so remember this is the existing ports and this existing replica set. This hash is same as this. We have changed only the configuration of deployment. We have not started the rolling update yet. Now we'll start the rolling update here. So now let's say you have changed the code of your application to fix some bugs and added some new features as well. Now, once your code is changed, now you want to build a new image of your code. And this is a command, as you know already, to build the new image. So here we'll use the same image and change the version to latest one. And this is the command to build the image. So I had already done it. And if you see the latest one for this image already exists with me. So I'll be using that. now, but in production, when you're during your development cycle, you need to build it yourself after adding new features or updating your code. Now what we are going to do is we are going to set this image. We're going to tell deployment, Kubernetes deployment object, the one which we created just now, tips app, that now the deal with this tips app container is a should be the new image. Basically what this means is that the images used in the container created by this deployment should be upgraded to this. Now how this works, so you had the top level deployment object, deployment creates a replica set, replica sets create the pods, and pods are created using some containers. So let's run this command, kubectl set image, and this is what I'm doing. So what, same name of the image, but the version is different. Earlier it was latest, now it is latest one. So I'm telling Kubernetes to change the image of tips app deployment to the newer version. So it got created. Now if you see the pods, you will see, let's see the replica set also. So now this replica set has a new pod, and if you see the pod, now there was one pod with the new version. Now there are two pods with the new version and two pods with the smaller version. Why there are four pods, even though you're given the replica set 3, we'll discuss that later, maybe in the next session. And slowly you will see the number of pods with the newer versions are increasing and number of pods with the older version are decreasing. And eventually you will not have any pod with a new version, with the old version. So all pods will be the new version managed by the new replica set, which is this replica set. Now you see there are older replica set which doesn't have any pod anymore, and the new replica set which has the desired number of pods, which is three for us. Now old replica set is also kept. Why Kubernetes does not delete the old replica set? Because if you want to roll back, and how do we roll back, we'll discuss in the next session. So if you want to roll back, it should have the old replica set to roll back to. Now what happens during the rolling update? So the earlier version of deployment had the version 1 of replica set. They were managing this earlier version of replica set was managing the version 1 of the pods. Once we told Kubernetes that there's a new image and pointed the deployment to the new image, so deployment ended up getting the version 2 of replica set, and which is managing the version 2 of the pods by creating those one by one, deleting this one by one and creating this one by one. Eventually the version 1 pods will go away and the version 2 pods will exist, managed by replica set version 2, but both replica set will remain to help us in the rollback if need be. So what happens, how this rolling update gets triggered? Once we are told deployment that is a new image, the control plane controller detects that new image in the deployment. So what is control plane? You would have seen that in the Kubernetes architecture session. If not, I will recommend you go and check that video out. So in the control plane controller, the new image gets detected. Then it starts the new replica set and new pods, and you have seen the cycle, and attaches the pods to the new replica set and deletes the old pods from the old replica set. Now the replica set is created by deployment automatically. We don't, you would have seen we never ran any command to create any replica set. We just set the new image, and the replica set and the associated pods with the replica set are created by Kubernetes automatically, and the old pods with the old version of replica set also got deleted by Kubernetes automatically. So this is a reiteration. Old version replica set is maintained after the update. So I'll stop this session here now. In the next session, we'll be discussing how the rollback happens. So thank you for watching. If there's any comment or anything, then please feel free to give the feedback in the comment. Thank you.